All right, guys, just a quick adjunct on ideal body weight. Okay, I'm going to go over the formula real quick. First of all, it's important for all of us to understand that if you're 5 foot tall, okay, that you're 60 inches tall. Okay, we're going to start with that right there. All right, when we're talking about ideal body weight, it's based upon the height of the patient. Okay, and we start everything at 5 feet. Why is that important? Well, because we give medications based on weight, and we provide ventilation based upon ideal body weight, which is based upon the height of the patient. Okay, so just because you're a bariatric patient doesn't necessarily mean that you have more lung tissue for gas exchange. So that's an important concept to understand. All right, so there's two different formulas, but they are very, very similar. You have a male formula and you have a female formula. Okay, and in males, we always start at 50 kilos. Okay, and in females, we always start at 45.5 kilos. And then what we want to do is we want to base, we want the number of inches that the patient stands above 5 feet. Okay, so that's really, really simple to get to. And what we're going to do here is my patient is 5 foot 4 inches, right? Or 64 inches. Okay. What I want to do is I want to remember that we're always starting at 60 here. So part of this equation is going to be starting at 50 kilos for the male and starting at 45.5 kilos for the female. Patient stands 5 foot 4 or 64 inches. Minus 60 means that I get 4 inches to work with. Okay. When I get those 4 inches to work with, what I'm going to do, okay, is I am going to do this. This plus is going to stay as part of this equation for now. And then what I'm going to do is I'm going to take 2.3, okay, times 4 inches. And this is going to give me a kilogram number as well. Same thing with the female patient. 2.3 times 4 inches, because I'm 4 inches above 60, I'm 64 inches, and that's going to give me kilograms as well. Okay, so 2.3 times 4 gives me 4 times 3 is 12, 8, 9, 9.2 kilos. Okay, so what I want to do is I want to add 9.2 kilos to 50 for the male patient. So I end up with 59.2 kilos is my ideal body weight. For the female patient, I'm going to add that 9.2 here, 5, 7, 14, and I'm going to end up with 54.7 kilograms of ideal body weight. Now, obviously, respiratory has this already worked out. The Fundamentals of Critical Care Society and a whole bunch of other groups and courses that are out there have this chart already done up for us. But what we do know right now is the ideal body weight for a patient that is 5 foot 4, okay, and male, is that I need to figure their ventilator settings based upon 59.2 kilos is their ideal body weight. If it's a female patient that stands 5 foot 4, I need to figure out their ventilator settings on their ideal body weight of 54.7. Okay, so that's important to understand. And again, it's quick. There's charts for it, that type of thing. But the reason why it's important is this last little piece right here that I want folks to understand. Okay, our standard formulas are going to be 4 to 8 mLs per kilo. Okay, and that's going to give you your tidal volume. You can go up to 10 mLs per kilo in profound acidosis, cardiac arrest, etc. Okay, when we talk about minute ventilation, we talked about that earlier. Basically, the way that minute ventilation works is that you're going to want a minute ventilation of 100 times the ideal body weight in kilograms. Okay, and again, that can start somewhere between 9 liters per minute and 10 liters per minute in the profound acidosis patient. So what does that mean? Let's just take a real quick look at this, okay? So if my patient's ideal body weight is 70 kilos, okay, so I have a 70 kilo patient, I've already done all the math, then that means that I can be anywhere from 4 to 8 mLs times 70 is going to give me my tidal volume. So if I go 4 to 8 mLs, let's just use 6. 6 is kind of a common, 6 mLs per kilogram. 6 times 7 is 42, okay? That's going to give me 420 mLs as my tidal volume. All right? My ideal body weight is 70 kilos times 100. That gives me 7 liters per minute as my minute ventilation. The only thing missing here now is the respiratory rate. Okay? So in the way that I get the respiratory rate is real simple. I divide the 420 into the 7,000, and that ends up giving me 16.6. So my ventilator setting for this patient that's 70 kilos, ideal body weight, is going to be a respiratory rate of 16, okay? Respiratory rate of 16 times a tidal volume of 420, okay? And that's going to give me my minute ventilation. So 16 times 420 gives me 0, 6, 2 is 12. Again, I'm terrible at math, 25. And then 4, 2, 0. And I've got 0, 2, 7. I've got 67. The minute ventilation is 67.20. Pretty damn close. Okay, and that's where I would start. And we talked about it earlier. If this doesn't produce an end tidal that I am looking for, then what do? I can change the rate. So if I change the rate by 2 here, okay, then what's that going to do? It's going to add roughly 900 more to this, and it's going to give me somewhere around 7,600 as my minute ventilation. Okay? Hopefully that makes sense. It's just a real quick formula. Again, they have the flip charts like on the carts in many places, and I know the respiratory therapists carry them as well. But our standard setting should be based upon this. Most patients are not going to tolerate 12 and 500. 12 and 500 is going to put them at a deficit already on the ventilation side, which is going to be problematic because it's going to make the patient more acidotic. Okay? So again, 4 to 8 mLs per kilo for your tidal volume. And your minute ventilation is going to be 100 mLs times the ideal body weight in kilograms. That tells you how much you need to move in a standard minute. Respiratory rate is typically going to be somewhere between 16 and 18 to start. Your PEEP is going to be somewhere between 5 and 8 to start. And your end tidal, we're always going to target the end tidal at 35 to 45. And we're always going to get that sat somewhere above 94%. So hopefully this helps. Thanks for your time.